Serge. I'm in 4th year mechatronics engineering. I've been in the team since 1A, so almost 5 years now. And yeah, I'll introduce you guys to the team, give you guys a bit of background about what the team does. Then we'll go over kind of like what the competition that the team participates in, what we're doing this term, which is helping you guys get a grasp of what we do for this term, and the small student competition that we'll be hosting this term between you guys, so that we'll expose you guys to kind of what it takes to build an aerial system. We'll give you a quick system overview of our systems, what makes them up, and kind of just a really quick overview of what you'll be learning in the future workshops. So if you've ever been interested in aerial robotics or just robotics in general, these workshops should hopefully be really enticing for you. So to give you a little bit of background and kind of like the history of the team, we started in 1997, and we are almost 22 years old. So the founders, kind of a fun fact, was Dave Crotch, which is the founder and CTO of Arion Labs. If you guys don't know what Arion Labs is, they're located in Waterloo, and they kind of do this as their business. They build drones for the private sector as well as the military. We are the only ECE student design team, to my knowledge, and we host student learning as our #1 priority. So in the past, we've basically customized all aspects of our systems, from the actual frames that we use, the mechanical frames, all the way to the autopilot hardware and software that we use, as well as other aspects that you guys will learn about today. So in terms of our competition, Roman will.
Before I start, I'll just introduce myself. I'm Roman. I'm a 3rd year mechanical engineering student. I've been with the team since 2A, 2B, so I've been here for about 2-3 years at this point, 2 going on 3 years. I'm helping out with all the mechanical things on the team. So the competition that we used to compete at for the most part has been Unmanned Systems Canada, their student competition. And in the future, we're considering competing at the AUVSI Student Unmanned Aerial Systems competition, so SUAS. The 3 competitions we have listed here, those are the previous 3 years competitions from Unmanned System Canada. So we had a simulated police evidence search, and we had to do like an egg deployment and pickup. It was like a secure listening device that we had to handle very gingerly. The year before that, we surveyed a large area for bird populations and retrieved an egg. And the year before that, we had to locate an IR beacon and drop a package to its location. These competitions start favoring multi-rotors, and from the beginning, we've been kind of like a fixed-wing centered team. So that's why we're considering doing AUVSI, which primarily always usually favors and prefers doing fixed-wing aircraft and airplanes. So this is just a picture of our team from last year. So this was the multi-rotor that we flew at our Unmanned Systems Canada 2018 competition. So it was a multi-rotor that, from this picture, we modified it for even more power, more lifting power, more bigger motors, bigger props, so that we can actually fly to the endurance and the payload requirements that we needed. And this is our team in January of 2018, so about basically a year ago today. Yeah. Just some important links that you guys can look at to get a bit more information about what's going on with the team. UWARG.com is our team website. That's where we kind of promote and show off all the stuff that we're working on as like a company, so to speak. Our communication channel is uwarg.slack.com. That's where we post a lot of information. That's where you can get in touch with anybody from the team. Our documentation is docs.uwarg.com, and we have a YouTube channel with some interesting videos, like a bucket quad that we flew in 2017.
There's no sound, but it was a...
There's no sound, but it sounds like an angry beehive.
So the frame was actually made out of like one of those 5-gallon Home Depot buckets that you buy for like $5. Because it was kind of, the build was rushed, but we attached 4 like airplane grade motors to it, like ones that can power like an entire plane.
Like a fixed wing.
Yeah, fixed wing plane. And
yeah, the idea was to have the bucket as basically a frame that we could mount like an aperture type mechanism to kind of land on something, close it, and take off. It was a bit ambitious and it ran into some issues, but we did get a flying Home Depot bucket, which was definitely the wild card.
oh, there it goes.
That's pretty fast. That's scary fast. If I see that coming towards me, man. Oh my god.
That was narrated by me as well.
Yeah.
I think we did a launch off at some point as well.
Or you just punched it.
Yeah, we just went up. I think this is the video. So
That was full.
that was at like 50% or 70% throttle. Yeah.
Were you guys controlling it or was it?
This was manually controlled. This was by our pilot Steve. So when we're testing this kind of stuff, we were testing like the aerodynamic worthiness, if you even want to call it. Airworthiness. So that just like in a matter of seconds, that went like.
It's really just a testament that if you really try hard enough, you can turn anything into a quadcopter.
Yeah.
We've proven that.
Yeah, we got some looks at actual competition. We definitely had a popular quad when they saw the Home Depot logo, even though we weren't sponsored by them.
I'm not sure that was full up. Probably wasn't.
So yeah, this gives you a little bit of an overview of like what the team does. So we try to keep it fun. And so, yeah, go ahead.
So, a bit more overview on the term and what's going to be going on. So what you're going to learn in these workshops, you're going to learn really what it takes to design, build, maintain, and actually operate these types of aerial systems, as well as just the basic mechanical, electrical, software concepts as you need to know them to build one of these systems. It'd be a basic overview, but it's a good way to get you into this type of scene and basically find out what you need to learn more about and basically get like the basic concept. Stuff that you probably won't learn until like late 3rd year, early 4th year when you start taking technical electives, but stuff that you do need to know to actually build cool stuff. So we'll be doing basics of flight and aerodynamics. We'll be doing UAV power systems, so basically batteries, motors, speccing and selection for all of those components. Communication methods and protocols, so different RC protocols, different software communication methods that we use with our autopilots, as well as low-level control, basically how to actually keep ourselves stabilized and flying, and high-level control, which is really to actually perform the mission that we're doing. So low-level control would keep us stabilized and at the spot that we want to, and high-level control would let us actually program a mission and fly to various points to survey an area, for example. And with the competition that we'll be getting you guys to do, so you guys will be tuning a quadcopter based on a pickstock microcontroller. So these are commonly used in the competitions that we fly in. A lot of teams end up using these. They're, I think, open source flight controllers with a lot of capability for both basic functionality and advanced functionality. So you can, in addition to just keeping a quadcopter or like a multi-rotor plane stable, it'll let you fly to GPS coordinates and perform missions that you pre-planned ahead of time. So you guys will be tuning one of these to fly this quadcopter basically through a series of trajectories and a series of points, and you'll have to know all the various aerial systems and various effects that are in play here, as well as basic control theory for PID2, which as a third year mech, I'm only learning in the second half of my controls course, so this is a good head start for that. But it's not that scary, don't worry about it. And a bit of a timeline about what's going to be going on with these competitions. So today we're just doing an overview of our system. Next week we'll have Eric, a fourth year mechanical team member, go over the fundamentals of flight, power systems, and a bit of communications with Serge as well. The week of midterms and reading week is a bit of a TBD at the moment. We're going to see how we can slot things in. We're recording these videos regardless, so even if you can't actually make it to one of these workshops and presentations, you could always just look at the video online and kind of catch up. And you know, if you're just kind of bored and you don't want to work on your problem sets, then watch us. Then after
like
that,
and subscribe.
Yeah, smash that like button, guys. So after that, we'll be going over high-level controls, so basically our ground station waypoint things. And then after that, we'll be looking into tuning the aircraft, and then we'll be tuning and testing for 2 weekends, and then you guys will be competing at the end of March.
Yeah, cool. So before I just jump into this, just to reiterate on what Roman said, whether you're in mechanical, electrical, software, whether you're even in engineering at all of these workshops and tutorials will be aimed at complete beginners. So right now, if you don't feel comfortable with kind of some of the topics that are on there, please don't feel intimidated. We will be aiming them at complete beginners. So we will start from the very beginning. And we feel like these things are just, even if you want to join the team and only focus on the software aspects of things, and for example, the autopilot, we feel that just knowing and having a high level understanding of like all of the components of these systems is highly beneficial to be able to succeed in developing them. So to get into the system overview, so I'm just gonna describe kind of what's out in the industry. So what's out in the industry and kind of what we did with certain aspects of these systems. So say you have an RC car, say you have a quadcopter, say you have an airplane, right? All of them fly by themselves. What are the similarities between all of them? If you want to make them autonomous. Believe it or not, it's actually most of the components inside them are very similar, and we'll cover all of them. So by the end of these workshops, you should be able to build all three if you actually wanted to. So to get started into the airframe, as I mentioned, you can have a quad, you can have a plane. You just outfit the inside of these systems with sensors, controllers, electronic speed controllers, motors, and basically allow your plane to control itself, or be able to control itself, and you can fly it. So this is, in particular, this is the Spike airframe. We've used this in the past 3 competitions, not including the last one. So it's kind of like a styrofoam airframe. You can buy it for $100. If you crash it, you can tape up the styrofoam if you can do that. So it's pretty versatile, and it's just an overall nice airframe that we've used. On the other kind of spectrum, there's a hexacopter that you guys see on the left. It has basically most of the components of the airplane inside of it. A little bit different to control, but in essence it's the same thing. So you guys are going to be working with quads, just because they can be flown indoors without crashing into walls easier. We'll try to rent out, we'll see where we can fly it. We'll try to do it with the RoboHub, like the new space in E7, but we'll keep you guys updated on that. Then there's the autopilot and controller. This is one of the most sophisticated aspects of these systems, but they essentially do the same thing. We will go into far more depth into later workshops as to like what's actually in one and what they do. But essentially, it's a system that has a certain set of inputs, which are the sensors, which we'll talk about later, and a certain set of outputs, which are, for example, the motors of your airplane that make it fly, or the flaps or the control surfaces that maneuver it. So on the left there is kind of like our prototype autopilot that we started working on about 1.5 or 2 years ago. We call it the Zero Pilot. This team does hold student learning as a #1 priority, which is why we even bother with such projects. We think that there's a lot to learn by developing your own systems. The one on the left is based on an STM32F7. If that means nothing to you, then I don't think it should. It's just something, it's like a processor that we will get into later as well. And on the right is kind of like the commercial system. So this is a pretty big hobby and quite a large industry as well. And there's obviously a lot of players in the game, one of which this is a really popular one. So this is like an open source flight controller as well that you can yourself buy for about like 150 to 200 bucks. So they are kind of pricey, but basically you plug in all your sensors like the GPS, your motor controller is in, you put in a battery, and it basically has some software on it, which is the firmware that lets you control it. So kind of the two spectrums, the customized one and the one on the right. Even though they look drastically different, they do perform the same function, and they do have almost the same capabilities. In terms of the onboard sensor, some of which that you are pretty popular to see in aircraft especially, would be like the IMU, which basically allows the airplane to understand what orientation it's currently in. The GPS, which doesn't look like that in an airplane. It looks like a module on the left, but it lets you know where the airplane is in open space. There's the altimeter, which lets you know how high the airplane is at the current moment, and you can add more sensors on to fit your needs. You can add an airspeed sensor and so forth. Now we'll be going in depth into all of these, why you would want to use them, which ones wouldn't you want to use, for example, why you wouldn't want to use a GPS indoors, and so forth in future workshops. And then there's the ground station. So this is kind of like the high-level control aspect of it that we were talking about before. So once the quadcopter is flying, how do you make it do useful things? Well, that's where the high-level planning aspect of it comes from. So this is usually done through some kind of communication system, which we'll also get into. And that communication system communicates with our aircraft to tell it where to go, essentially. And it also updates us on the status of it. So if our airplane's about to do bad things, we should hopefully know before it does them. So on the left, I'm going to start with this one. So when the team started when the team started building this thing 5 years ago, that's our first version of like a ground control station. So this is a piece of software that would run on your computer. It would connect to some kind of communication system, as I said, and it would display things about the airplane, like its current orientation, where it is on the map, what your mission plan is, and so forth. This was the second iteration with some more fancy things that I had a big part in. And this one, as you can see, is far more superior because it has a 3D view of the airplane as it's flying. So it has those dang points. So, and this is kind of the commercial one. So this is, so as I mentioned, the Peacock's system beforehand. This is what you might use if you're using those kinds of systems. So there's quite a lot of alternatives available in terms of doing planning these systems. And I think you will be mostly doing this one for the actual competition. You guys will be getting familiar with kind of the industry tools. And yeah, finally the tracking antenna. So planes can fly, our systems can fly kilometers away from where we are, beyond line of sight even, right? Usually a regular antenna can't reach that far. So what can we do? Well, we can point an antenna at it, and we can track it as the plane moves, or quadcopter moves forward. And that's kind of what the tracking antenna does. It's a pretty vital system in terms of making sure that the airplane is always in the radio line of sight so that we maintain communications with it, and that's what that system does. It's surprisingly a pretty hard thing to do. In our previous competitions, no matter how much we seem to have programmed it, we always had one guy just pointing at the plane with his hands, pointing the antenna with his hands. Yeah. Cool. And I think that's about it. So this was meant to be just like a very short introduction into some of the systems that we work with. We will go into depth, much more into depth into later workshops, into each of these components. And again, if you miss a workshop, we will post YouTube videos on our YouTube channel. Please do join our Slack, because that is the main communication channel for the team. Yeah. Do you guys have any questions?
Wow.
Yep.
Is your goal sort of to go into aviation later on?
Mine not. I joined the team particularly because these systems are, I think, the most complicated in terms of what other teams do as well. Like I was interested in robotics, and you can't get more complex in robotics than an aerial system. There's just so many things at play and so many things that have to go right for it to all work properly. One system can compromise everything else and you can crash the plane. So I kind of like the challenge aspect of that, which is why I joined the team initially, and which is why I'm still here. Yeah, if you're interested in aviation, if you just want to know kind of the pinnacle of robotics and kind of like how to control these systems, this is an interesting project to do. So yeah, if you guys want to come down and check out the bay as well, we'll kind of host a little viewing party as well. You guys can feel free to come over here, check out what the quadcopter that you'll be working with, what it looks like, the autopilot, what that looks like. This is kind of what we developed, and the Pickox, which is dropped. It's okay. It's already broken. So
Yeah.
yeah. If you guys have any questions, feel free to ask me, Roman, Annie, or Elton joining us today. So yeah. I hope you guys find the future workshops interesting. So, thank you.
Yeah, thanks for coming out, guys. We appreciate it.